So in here, you can directly choose your preference for like thinking that work and explore everything, or you come up with arguments. It's needed, it's time in here and like if we want. And yeah, if you want to learn something randomly, it's try to think here, you feel want. Maybe there's like a full wag blue, but it's a game. Not even it's pretty good. You know, fine, I think that see what we find using our optimal images and your own taste. Yeah, it could be just as simple as I think start with the Google Workspace tool. Yeah, it could be just as simple as that. Once so the tool is force that you come up with like some kind of score or like badges. Yeah, what view is the basic in here. Have our page here. Nice, right? And so you can set like, yeah, I'm in the middle for your sounds. This thing actually could be done in with 10 minutes, even like 45 minutes here. Let's say median thing, it'll be straight in progress here. This thing if we let you start the lab here. Okay, so you can see we have functions like Gmail, start Gmail, try to put around and usually to new technique. After that, they'll found wait. You can whistle, you know, after you go up to Google Space, okay.
When it comes to Google Workspace, I'm a power user. Maybe a little too powerful. And when I say power user, I mean across all the Workspace apps. Drive, Chat, Calendar, you name it, I got it down. Through those courses, I learned how to do things like customize what details people can see in my calendar, or how to protect changes from being made to certain cells in Google Sheets, or even how to modify the theme of a Google slide to match my company's visual style.
Yeah, but I can't add a message to a folder in Gmail.
You can. They're just called labels. And V on the keyboard is a quick way to add one to an email.
Okay, but what about quickly adding a date to Google Docs without having to type it out?
Smart chips. You can type the @ symbol for a quick and convenient way to add things like a date, or even link to people, files, calendar events, places, and more, all without leaving your document.
Well, what about...
I'm gonna stop you right there, because if you're asking these questions, then the Workspace courses are right up your alley. Check them out now and become a power user like me.
Honey, how do I move something to a different folder on Google Drive?
1 second, Mom, I'm doing a video. Amateurs.
Improve your skill with some certificate on the math, something like that. But for today, yeah, we will move on then. The project. So yeah, let's do the quick recap from the last time. Here we have the AI generated user topic here. So we have hardware, we have the software, skill, yeah, and come up with like kind of research guideline. The AI say this report only is not my report yet. You like how like a lot of things. And they say it's not proper comment report research. Also, you like a lot of literature reviews, references, you know. Also, the very old modules. But still, it gives an idea, a very good idea of how to implement this hardware, which is fine. Have two of them, you can try this thing. It would be great if you can make a presentation with the hardware. Then much more easier, much more better. Yeah, so it's just like, yeah, they introduce some project about with basically just how we calculate, yeah, well, take a photo just before your meals, or just before you decide to buy anything from online platform. You can the photo input, image input of the food input, and come out with basic information, especially narrow. So also they also get some idea about egg point, but this time we are not using sensors. It should be showing egg quality monitoring. To photos, possible snapshot in sky, using the pace, if there is a see that they mentioned about this Max 5. So that is the processor of our camera, of our AI camera.
And today I provide you the information about the M5 sticks. Yeah, that is the name of the AI camera model that we have here. So this is the guideline. So just yeah, you can find yourself. Yeah, so this is the classical way to learn something. Equals here. Implementation. We learn about specification. We learn about yeah, how do you yeah, apply things like that. But why call this thing classical? But like these days, people love to learn from the top to bottom. Both. Maybe the top bottom. Maybe the top approach to the bottom one is simple. Just start with the application, right? Go see the final output of this thing. And after that, just go through all the way to each layer from the application layer down to software lower to the machine. Yes, so we have like a high level language and low level language down to machine language. After we go down here, both ways. These are all different. Maybe it's kind of useful for you. We also provide you the research aid to the targets part. Yeah, in my opinion, it's setting up. So that's why I provide you the guideline for you. Just take a look at one reference here we have. Yeah, so let's start from the first reference, which is, I think, is the official website for also the architecture of this thing. Yeah, so this is what it looks like. Spreadsheet, not properties, but pretty happy to live with it. Okay, so this is kind of yeah, specification, application, and yeah, we need the micro the micro SD to give them the database and also the basic commands like here. So these are the chipset. It's called the CanDrive K2. So this is called the open access. So let's say if we want to do this thing. Prototype of your own project. You just click down this blueprints and build up, fabricate your prototype. It is provided here in the blueprint. So just find start on the drive. You need to connect because this the intermediate drive is like once we hook him up with the PC to power up his plane, this kind of welcome interface here. This thing is called face detection, object detection. So it could be face animals or any object should want to detect this screenshot of this. But again, actually easy around with the driver for 30 minutes to this. But once you start with the first example, you to start to work on the project here. Lines for you here that I made up for you, and this is the Google slide just for this presentation. So we have the first is the hardest part prerequisite and hardware checklist. Yeah, I had everything in here except the USB-C cable, which is not here. Actually, last whole page. Upload the program all voting provided to me here, but also is 90 internet with it. Right. So it's 90. First example, what you download, you download to one, and we will just you take a face when human face, you webcam is not enough. Why is so called the AI camera? Yeah, because it's running it independently, and that's what is called embedded. So you don't need to access to the internet by operating. So it's given this model, and will work on that. So imagine it's like say self-driving car. So we have to hash the software, not just mine, but why are you are driving? Yeah, don't really need the internet access, making you autonomous and the braking, all the parking, everything is all embedded. It's already there. All it works fine. So you don't need to access to the internet, worry about the lagging, latency. Okay. Yeah, so this is how we do it. Yeah. Okay, this is how it's like when you integrate with my
for Python. So this is the face detection. So you can see like they try to draw the outline. This human face. Well, yeah. Today I'll be introducing machine design. Pretty much the same thing. You can see the outline. Try to big outline of, and once it turns into this thing, it's called video extraction. Machine is not really looking at its guide face directly. In other words, they didn't change these colorful into like pixelate data and compare at a time. When they extract that photos into some kind of, they can see like simple lines there and there, like square shape, circle, round, pattern here. So this is what computers see in. That's what we call feature extraction. So we extract something important of some data. Yeah, another example of the feature extraction is a sound. Yeah, you might ever see like it's called a spectrogram of the sound. Yeah, so this is what it looks like. So we extract some sound. Yeah, actually the sound. This is the original one. We call it time zoning. So you can see like this platform like get sound and goes up and down. Yeah, so this is another way to extract. It's called video extraction of the sound signal. So you can see frequency range and turns into some kind of this like this kind of data is not, it's possible to do some kind of processing, but it's not that clear. So we can use this kind of technique separate under the extraction of the data here. So like this example, we can see market. You can use the signal to like we have a lot of indicators to extract some information about stock prices or like just the graph of the market price. It's just part of what it's called the feature extraction. Yeah, so for today, I think it's a good way to learn about the extraction of the image. So I provide you another self-paced learning. But this one is optional, so um, I'm not going to put on this onto your old school things. But I think it's a good way to learn about face recognition. Yeah, again, on the MATLAB platform. Okay, just click here. So it's called a computer vision. Just let's start here. Yeah, actually the course itself, it takes only 1.5 hours. So actually, one class. No. But yeah, so yeah, so let's start it right away. So I think it's a good way to learn the image or the vision. So this is another way to build some project. So hope this can give you some basic idea about some like final project.
Hello, and welcome to Computer Vision On-Ramp. Humans take in a lot of information without even thinking about it. Whoa, that's a cute turtle. Hey, so is that. Whoa, there are a lot. And they're walking away. These images are all different parts of the same scene, and they fit together to create a bigger picture. Computer vision is where knowledge about the real world and digital data meet. Data from multiple cameras and sensors can be combined to create a digital reconstruction. In this course, you will use object detection to find, track, and count turtles in a video. You don't need to learn a lot of theory to start working with video files, but it will help if you know a little bit of image processing, just the basics. If you've never used Image Processing Toolbox before, it's easy to get started, and we recommend you first take Image Processing On-Ramp to get you up to speed quickly. Throughout the course, you'll be interacting with the web-based version of MATLAB inside our training environment. It has a slightly different look and feel for MATLAB Online or the desktop version of MATLAB, but don't worry, you're using the exact same MATLAB language. Enjoy the course!
Just going to be how you may import video files and how to read this kind of file. Okay, this is the flow chart of this object injection. It would be great if you take a look at this one flow chart and summarize all of the overall process. We just starting from that side. As said, we import the video data. Later, from data. When you train it, you usually heard this thing when we dealing with some kind of generative AI. It was the same thing. We train them, teach them to be smarter. And the next, when we can do detailed objects, we come up with the exact objects. So these are the outline. So if you start from video data, after that, we use the features, the detection, and the object tracking. Yeah, just watching one video and click the next story gave you like 6% already on this course. And if we don't want to see, it's optional. I love to see it. Like if you finish this thing. And let's take a
A
look at
turtle's
another
life
video
starts
here.
in the sand. Once they hatch, they need to find their way to the ocean, where they'll grow into adults. This journey across the beach and into the water is a critical step in their life cycle. Researchers monitor their movements by setting up a camera on the beach. Video like this can be used to detect baby turtles and track their journey to the ocean. In this course, we'll use video from a mobile phone taken on a beach in Esmeraldas, Ecuador. To track the turtles, you will first detect them in each frame of the video. Like that is a turtle. There are a bunch of turtles, and they're located here, 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 and over there. You get the point. Before you can identify and locate your turtles, you need to access the video from MATLAB. The first step is to create a video reader object. Let's get started.
Okay, just like the Python and the other programs, we have to access how to read this file. So first we start from the most basic command. The command then to read the video file. So this is the first example. We're going to use this command. Follow this instruction. Create a reader name the turtle video from the turtles.avi. So I will save this, copy this one, and just perform the video reading command here. Video reader. And inside the syntax, the argument here is a file name. So make sure you have the double quote to let them know it's a string input. So we could hear things. Just hit the submit button. Okay, and once nothing's wrong here is correct, we're good to go to the next task. Once we read the video, you're going to see our workspace. We have some so you can think like so like here, but inside of it, can view probably from your file. It contains so many information like the duration, how long it is, like the time, all number of the frames. So basically, the video is just a bunch of photo frames connected together. So this task, oh, this is a practice. So yeah, you can just see the information by using this syntax here. This is a video file that we read, and yeah, you just find some information like the duration name and everything. Just change the arguments here, or you can just directly click it in your workspace. Yeah, so you're going to see like a bunch of, I don't know, strings. Yeah, what else? The double arrays, and also, yeah, there's somewhere they keep all the images here. They can see the size here. So let's go to the next section.
Take a look at these images. If we look at them quickly, one after the other, we see motion. Videos are a sequence of images called frames, usually taken at fixed time intervals. The number of frames per second is called the frame rate, and it tells a video player how fast to display the images.
Okay.
In a video file, the frame rate and other properties are stored alongside the frames as metadata. How do you work with all that information in MATLAB? Lucky for you, a video reader makes that easy. With a video reader, you can access metadata and individual frames. You can read one frame after the other, or skip around in the video. The video reader will keep track of where you are in the video, which frame and what the current time is. When you read in a frame, it is itself an image, a three-dimensional array of red, green, and blue intensity values. In MATLAB, you can work with it like any other image, using image processing or machine and deep learning techniques. So video processing comes down to image processing, again and again and again. And it all starts with the video reader. Let's see what it can do.
Okay, so this is the next tutorial. After you create the video reader, you can just use the read frame to extract the frame from the video file. So let's say this task, we just create an image named frame that contains the first frame of the video. Okay, so of course, let me guess, I have to do the read frame, maybe just here. And after that, I need to choose the turtle video. Yeah, I think this will do. Oh, the frame access, how we define it correctly. Okay, let's see how we define that thing. Read frame. So we have to use the frame number, the total video. And let them check again. Yeah, so that's all. So you want to see this variable, just go to the workspace again, and this is the first frame of this video. And just take a look at it. But if you double click it, you expect to see the video. Colorful image. Actually, it turns into a bunch of numbers. That's now the machine, the computer, take your image. That's how they see our image. As a bunch of numbers. Okay. So this works the same way, or the AI generative. They just think about the next frame as the next number. The predictive model will predict the next number as well as the next frame and which of the video. Those are like they work. But this time, yeah, we're going to do the detection. So we're going to play around with these number, of course. But we didn't finish yet. Yeah, we just gonna display. So we have the specific command im show. Yeah, so here im show. And we're gonna display the first frame, which is the frame here. Okay, so it's supposed to display like the image that we expect to see. Yeah, in the output pane. So I will minimize this line and let's see. So this is how it's supposed to be like here. So this is the first frame of this thing. So we can see basically just, yeah, the image, yeah, the normal image, nothing like big. But remember, what the computers or the machine see is a bunch of image number behind in this image. So this pixel is going to be some image. Yeah, I can see the dark spot here. It's supposed to be somewhere around 200 to 255. And the white spot here is going to be very low, somewhere around from 0 to 10. So basically, what we see and what computers see. Yeah, okay, so that is for the task number 2. Okay, let me minimize this output pane and go back to the task here. Okay, next task. Let's see, not this one. We want to access current time of this video footage. So we have the t as a variable that will contain with the obj. Okay, let me do it again. Yeah, it should show you some suggestion here. No, it's not. Let me see the hint. Yeah, the total video. So we start with the object. Yeah, we start with the object. So the object is our video. The, the turtle video here. And don't know, it might be duration. Right, duration. Yeah. TX. Oh, the current time. So we use the current time.
So we are not going to use the duration. We're going to use this one, the current time. If you want to see the current time of these things, just submit it. Okay, I think we're ready for the next task. So we're gonna see some output here. Let's check some output. So it's going to be like 0.033. And this is first frame, and yeah, it start at some like 0.3 seconds. Where that number came from. So you can see the current kind of frame, more frame rate is similarly we take more slow rate, right? So let's say the first dynamic model last year, like every day, 0.3. So the current time we see. When we extract the first frame, once we start the first frame, we need current time 0.0. Here's the question: what is the next time for the second frame? Now, of course, it's going to be 2 times of this number, 0.66. And again, next question, you can test the next time that is spent on the third one, and so on. Okay, now if we want to see the ideal frame, yeah, like it looks like rewind or fast forward to any frame that you want to see. This is the first frame, version 1, take 90. Okay. So you can go back and forth between um, the the image that you want to see.
Take a look at these images. If
Okay, I think this is the last task, task number 4. Because the triggered task, we know the value of the t, which is 0.03, which is 1 over frame rate. So in this video, what create on the line 1, the current time, well, it was you. You just throw in 2 images and see the differences between. Okay, that. So we're used to, we're going to use this command here. So this is a task number 4. Create the image named frame2 that contain the second frame. Okay. We can see that they gave you a lot of like here frame. So you can have like the frame, read frame, the total video. So we still use the same here. The image one. And we will extract the time, the T2, by using again the same command here. So it's not finished yet. Have to display together like the frame number 1 and the frame number 2 by using this kind of this command. Image show compare. So we have the image number 1. Which is the first frame and the frame 2. So this is going to be, done. The last part of this thing. If you want to see the comparison between those two images, it would be in the output pane. So just kind of blurry image, but closely you got to see the green color and the magenta color here. Yeah, so it show you the movement. Yeah, that makes the motion pictures. Okay, so you can see like the difference. So it like the overlay of two frames, the first frame and the second frames here. The green one and the magenta one, the purple one in order. So that makes the comparisons. So this technique is be useful for, let's say, speed calculation on a car. You can just basically calculate speed very easily. The first frame, the second frame, and divided by time. So when you see speed equivalent to distance over time. Yeah, so basically difference in those two frames, distance and speed calculation. That is one application that we can use of this video extraction. Okay, so that is that is the first example. I think that is this is a further practice. What to do here? Okay, this is the very last example, last lesson for reading the video. Okay? So we're gonna go to the 90th frame. Yeah, let's see. Looks like okay, we have like few tasks here. So let's go like very quickly. Okay, the first one we're going to use just read. Yeah, the first input we already have here all the video. The video reader ready. And we just want to extract the frame it. Let's see. That contains the 50th. So right now we have what again? We have to use that one. Yeah, they suggest to use this thing. And after that, we're going to use the index. So let's go to the 50. I think that will do for the first task. Oh yeah, we have to add one more thing, which is the T mid. Yeah, T mid, which is the time in the middle of this frame. And let me try it. So again, we're going to extract the properties of this thing by using the current time. So we start the data frame mid. Current time. What is it? Yeah, the current time. Let me see a solution again. Current time. Read dot. Yeah, we have the bad memory here. Or the frame. The turtle video. Oh, here, yeah. Turtle video. Guess what this thing will do? Things. Incorrect again. Frame it displayed. Yeah, I think we need another current. Oh, we have to import. So I'd like to stop here. So it's about time. The class is finished.